Hi everyone, my name is Nguyen. I am a PhD student at Department of Computation and Software Engineering, Auburn University. Today I'm very pleased to present our paper named Code Recommendation for Exception Handling. As we all know, exceptions are unexpected results occurring while a software system is running. Failing to handle exception could lead to system crash, resource leak, unexpected result, etc. So handling exception correctly is very important. Studies show that correctly releasing resource in a present of exception could lead to 17% improvement in performance of an application. But exception handling is also challenging due to several reasons. The first reason is that API libraries are often very large. Android API consists of over 3,000 classes, over 35,000 methods, and over 260 exception types. The second reason is that the documentation for handling exception is often insufficient. For example, a study showed that 69% of the methods from Android package had undocumented exception. And the third reason is API frameworks are often upgraded quickly and include very large chain. Current support for exception handling is limited. Current IDE only support adding try-catch block for track exception. They do not support runtime exception and runtime error. So programmers still have to determine what code fragment to protect with the try block, what exception type to handle in the catch block, what to react when such an exception occurs. In this paper, we introduce FuzzyCatch, a code recommendation approach for exception handling. FuzzyCatch can predict if a runtime exception potentially occur in the code snippet. FuzzyCatch can generate the try-catch statement with the catch block containing code to recover from an exception. FuzzyCatch is based on fuzzy logic theory. It includes two models: X-rank, a model to recommend exception to catch; X-hand, a model to recommend handling action. Fuzzy rule for X-rank and X-hand are learned from a dataset of high quality apps publicly available. Let me introduce X-rank, a recommendation model for exception type. In X-rank, the problem is, given a code snippet C, we want to determine the runtime exception E with high possibility to occur when C is executed. For example, given the code snippet below here, this code is dealing with quitting bitmap. So we want to predict that our memory error is likely to occur. The idea of X-rank is that we want to learn the pattern from the code already written in high quality apps. So we collect a large collection of high quality code D. We look at every method called M in D. If N is often associated with the exception E, for example, M and E often co-occur in try-catch block, then it is likely that calling M could cause E. So going back to the code snippet C, X method M in C could have several exceptions associated with it. So we need to combine and rank those exceptions. For example, in the code snippet here, we have the create bitmap function, and we also have the draw function. So we have to combine and rank the exception that associate with two methods. in each rank, we want to learn the rule that the fuzzy rule that if we call method m, then catch exception e. So we learn this fuzzy rule by defining association score between a method called m and exception e. The score is computed as the number of time m and e co-occur over the number of time m occur. So with the association score, we can rank exceptions for each method. For example, in the table on the right, based on association score, we can know that number format exception is highly associated with pass-in method. Move to first method often associated with sqli exception, and media player dot get duration often associated with illegal state exception. So for code snippet C that contain multiple method code, the association score between an exception E and C is computed based on the association score of each method code M in C. The second model that we introduce is ESEC, which is the model to recommending handling action. Previous studies suggest that in most cases, programmers often call only one method for each object when they handle exception. So in our approach, we use ESEC to only predict one method code for each object when exception occur. Our observation is that resting code depends on the method code that potentially cause the exception in the try block. For example, in the if this one on the left here, given the method code in the try block, we want to predict that the method code in the catch block is get error stream, while given the method code in the try block in the if this on the right here, we want to predict that the method code is get a response code and disconnect. So in ESEC, we want to learn several fuzzy rules. The first rule we want to learn is that if we call method M in the try block, then call method R in the catch block to react or recover. The association score between M and R is computed similar to the association score in the X-rank model. We also want to learn another fuzzy rule, which is if exception E occur, then call method R to react or recover. Given these two association score, we can define the association score between method code R in the catch block and the code snippet C based on the association score for each method code in C and method R, and also the association score between the exception E and the method code R. Given the two models, we build a system to recommending exception handling code. The system, the model is learned from Android bytecode, so we develop a module to extract graph-based object use this model from Android bytecode, and from the graph-based object use this model, we can extract the co-occurrence between the method code in the try block and the exception type. Also, the method code in the catch block, and with that information we can learn the X-rank model and the X-hand model for recommending exception handling code. From the system, we develop X-Assist, which is a plugin in Android Studio. X-Assist could provide warning for a missing exception handling code. It has 3 levels of warning. Very risky is color red, risky is color orange, and less risky is color yellow. For example, here for the method code cursor dot move to first, given this method code, the system get a warning that the method is likely to throw an exception. So it indicates that we should handle a runtime exception for the method. In the second use of X-Assist, if we select a portion of code, then the plugin can generate recommend the exception type that could be cached, that we should get on the code snippet, and it can also generate the handling actions in the catch block in case we choose to handle the code. Next, we present our evaluation to study the effectiveness of FuzzyCatch. The X-rank and X-hand model are trained with Android bytecode. We collect over 13,000 top free apps from Google Play Store. Only app with an overall rating of at least 3 out of 5 is collect. Bytecode are stored in the .dex file. Then we build group model for each method implementation in a dex file. Next, we present the experiment on Android bytecode. We have 2 tasks. The first task is for each try catch block in the code of the testing app, we evaluate if FuzzyCatch can recommend the actual exception. And task number 2, we evaluate if the reaction method code in the catch block given the method code in the try block. In the setting, we use a 10-fold code validation to evaluate the accuracy of FuzzyCatch. We divide the dataset into 10-fold. Each contains roughly over 1,400 apps. At each iteration, we choose a fold for testing and the remaining for training. Then we measure the top grade accuracy. So here's the figure showing the result of each rank in recommending exception type. We choose a simple baseline for comparison based on the frequency of catching exception type. So from the figure we can see that each rank achieve very high accuracy, and is significantly outperform the baseline with top one accuracy nearly 80%, and top accuracy is over 90%. In recommending reaction code, we also choose the symbols byline based on the frequency of reaction method code. In this task, each rank also have very high accuracy, over 70% in top 1 accuracy, and over 90% over top 5 accuracy. We want to also evaluate the effectiveness of FuzzyCatch on real exception bug. We focus on the bug that caused by not catching exception or adding proper exception handler, and we also collect the fix to for comparison. So we identify the bug exception bug fix as follow. First, we determine the bug with a software system, either reported bug or on-demand bug. Then we filter and only choose the bug that contain at least one adding a catch statement. Then we manually inspect the candidate bug fix to find exception bug fix. Finally, we produce a dataset of 1000 exception bug fix. So on the right here, we can see there's an example of exception bug and fix. In the bug version, the programmer didn't add the try catch block for the code snippet. Then in the fix, the programmer adds the try catch block, and in this case, he catch the runtime exception. So we want to use FuzzyCatch to detect real exception bug, because our model can provide warning of missing exception handling code. And furthermore, we want to study whether FuzzyCatch can perform good on the task of predicting exception types for the exception bug. So as we can see here, our model perform 2 types of warning: very risky, and less risky. So if we set the warning to very risky, the system could detect around 75% of the exception bug correctly. For the task of predicting exception type, FuzzyCatch can achieve 75% top one accuracy, and over 80% of top 3 accuracy. So next, we want to evaluate FuzzyCatch on the task of repairing exception bug. Only 437 out of 1000 exception bug fix has exception had handling action in the catch block. So we evaluate FuzzyCatch on the 437 exception bug fix. For each bug fix in the dataset, we invoke ESEC, which is the plugin to recommend repairing action. Then we compare the recommendation result with the corresponding fix. For example, here is the exception bug fix. So we let ESEC to predict the handling actions and compare it with the handling action of programmer, which is the assignment with the get error stream method. In this task, we compare FuzzyCatch with two baselines, and we can see that FuzzyCatch clearly outperform the baselines and can provide correct recommendation in 65% of the time.